I'm not directly involved in that type of research anymore. In the past, I used to collaborate with one of the major players in the field, Khalil Bitar, and also years ago, we collaborated with Paolo De Kopp, who's probably the most representative author in the field of the bioengineering of the GI tract. However, my group has two different fields of research fields of interest. One is in patients. So we are working on, we have identified what we think is the most formidable platform where to study how the kidney repairs and regenerates. And these are patients who receive marginal kidney. And on the other side, at the lab, so this is a type of work that takes place mainly at the bedside. The other type of research, it's purely basic science at the moment. And what we're trying to do is, one, we are trying to understand whether, again, going back to the mitochondrial transfer, the infusion of healthy mitochondria procured from healthy cells into a damaged kidney may help that kidney to regenerate and repair. Then we are using the decellularization technology in order to obtain from the human pancreas different sorts of biomaterials that may be used either to help islet cells, so those cells that are in charge of the regulation of the glucose, to perform better and live longer, or also those biomaterials may be used, for example, to help stem cells to differentiate into the beta cell type of phenotype, as well as we believe that we can use those biomaterials as a cell culture supplement. And in the past, we've been studying also. We've been considering whole organs, decellularize as a platform for organ bioengineering, but we realized that technology is not feasible and implementable at this time. So somehow we put that type of approach to organ bioengineering apart. Whereas now we are using those scaffolds obtained from mammal organs in different ways, as I said, either as cell culture supplements or stem cell differentiators and similar approaches.